Here's a typical question involving a cantilever beam. So the first thing you have a cantilever beam. We know it's cantilever because it is fixed at one point, and it is quite obvious that this beam would be bending somewhat. What you need to be able to do is calculate how much it will be bending, where it is bending the most. As engineers, that tells us where we should reinforce the structure. Now the first sensible step to do will be to calculate your reaction forces and your reaction moment. So we calculate our reaction forces. We know that there must be a support force acting upwards from this point that is equal in size to the load placed on it. Here we can see that our support force, let's call this RA, for reaction from A, that is going to be equal to the sum of the loads, which is 15,000 newtons. Now that is not all, because there must be some reaction moment to counteract the bending going on, because otherwise this would just literally turn. So our reaction moment at A, we would take our moments about A. So RA does not have any moment because it's acting through the pivot, and we know that the sum of moments is equal to 0. So we've got our reaction moment, let's call that MA, and let's assume that that is going to be counterclockwise. Now this 5k will make it rotate clockwise, as will this 10k, so that is why it's got a minus sign here, because it's going the opposite way. So I've got minus 5k times its distance is 2 meters, so we times it by the distance, minus 10k times the distance here is 2 plus 2, which would be 4 meters away. And we know the sum of that is equal to 0. So that is going to be our reaction moment at A is going to take away 10k, take away 40k is equal to 0. So our reaction moment is going to be equal to 50 kilonewton meters. That is the required moment applied at A to counteract the turning effect of those forces. Now calculating our bending moment diagram requires us to take these and basically make cuts along our beam wherever we see an external force applied. So we're going to need a fresh sheet of paper. With the power of video editing, we have a fresh sheet of paper. So here is a simplified diagram. We know we've got 50 newton meters counterclockwise acting at our pivot, and we are wanting to plot a beam bending diagram for this. Now the easy cheat will be, well, easy cheat is we know at this free end the bending moment will be 0. So this means at 4 meters it'll be 0. We also should be including the other critical points from our example before. The beam is 4 meters long and we have a load applied at 2 meters and a load applied at 4 meters. This load was 5, this load was 10. So here we're going to have a critical point of 2 and a critical point of 0. Now we must cut at these critical points to find the bending moment. So we're going to cut at 0 meters. Cutting our beam at 0 meters, we've got this 50 newton meters reaction force on one side, and we have the rest on the other. Now you could look and calculate from this right hand side However, we can look either left hand side or right hand side. We see that the bending moment at 0 is going to be equal to minus 50 Newton meters. Why is it minus? It is minus because we are following the convention that if our forces are causing our beam to sag, that is positive, and here we see our bending moment that already exists would be acting counter that, must be a negative. So we will plot that on our diagram and we will make sure we label it as minus 50. And then we repeat the same thing. We cut at 2 meters. So cutting the beam at 2 meters gives us this intrinsic 50 Newton meters on the left. At 2 meters, we also need to include our reaction force, which we found before was 15k. The 5k load, which is why we've cut at 2 meters, is acting at the cut. That has no moment. On this right hand side, we have got a 10k. Now, this left hand side and the right hand side, we can choose either. This right hand side will probably be easier. So my bending moment at 2 meters would be equal to, I'm looking at the right hand side. On my right hand side, if I have a force that is acting upwards, that is positive, causing it to bend upwards. Here, this force is acting downwards, so it's also going to be a minus, and we can see that is going to be the size of our force, 10k, times, oh, that's missing a k off this, a factor of 1,000. Okay, so this is going to be 10k times its distance from our cut, which is 2. We can see it is minus 20 kilonewton meters. So our next figure we add to our diagram is 20 kilonewton meters, and we will join those two up with a straight line, and then we use our cheat, which is that the fixed end is equal to 0. You may wish to take a cut You may wish to check the cheat method. You can do this by taking a cut of your beam at this free end, which is at 4, and calculating what is the total moment exerted by all the forces acting to the left hand side of it. So you've got your 15k support, you've got your 5k acting here. This one would have 10k, but it's acting at the cut, and I'm going to leave that as an exercise for you to check. So recapping the steps you would need to take to solve this type of question. First, you would calculate your reaction forces and your reaction moment because it's a cantilever beam. Secondly, you would take cuts at your critical points, and you would plot those bending moments you calculate on your diagram, joining of course up with straight lines.